Welcome to Conversations with E. I'm Esther, or you can call me E, founder and CEO of Mind Myself. And back to our series, What's Light Got to Do with It? Welcome, Rachel Maurice, MD.
Thank you so much for having me, Esther. It's fun to be back. I'm excited to have more conversation.
Excellent. I'm just learning so much from all of the things you're telling me. Some of it's way over my head, but it's so important that we learn this stuff. Hidden truths that we have not been exposed to before. Woohoo. So tell us a little bit about yourself, Rachel, before we dive into mitochondria discussion today.
Okay. So my background is I worked as an anesthesiologist in Canada for close to 20 years. I left in 2021, which is just over 3 years ago. And I started to learn because I don't sit idle very well. I started to learn and uncover a bunch of information that I had not been taught in my traditional medical school education, which kind of crumbled the foundation of most of what I had learned. And not to say that was incorrect, it was just very incomplete. And so tying it into what we're talking about today is I was learning that light is the real driver of our physiology, and light signals all of the functions and processes that take place, and they go right to the heart of the cell, which is the mitochondria, and what we're talking about today.
Okay, that's a wonderful segue. Energy, mitochondria and energy. I know these are connected. Let's start with energy.
Okay. So the reason that we are alive today and is the fact that we have energy. I think everyone can feel it. We intuitively know that we have energy, but it's not something that's necessarily tangible. But the difference between us being alive and not being alive, being a corpse, is the fact that we have energy. And how we have energy is it's being produced in our bodies, in our cells, by little energy factories called mitochondria. So mitochondria, most people, I would say, can probably remember back to high school where they learned about mitochondria, otherwise known as the powerhouse of the cell. And, even my kids, when they were early on in high school science, would bring home, I think they had to do a little project, create a cell with a styrofoam ball, cut it in half, and put all the little organelles inside. And there was one little mitochondria. Well, the truth of the matter is that the average number of mitochondria, the lowest number of mitochondria that exist in each cell is about 500. And it goes all the way up to, I believe one part of the brain is 2 million
Wow.
in each cell.
Don't try and make that in your science project at home. You'll be a bit frustrated. Wow, up to 1 million in a brain cell. Wow.
Yes. And I think actually the egg cells have the most, which you can imagine, you need a lot of energy to create a new life. So yeah, we learn about them producing energy, which is very important, but we are not taught about all of the other crucial things that mitochondria do. So they are, in fact, antenna. So they receive information and they also emit information. And that's a critical point to note for us and us being alive, because literally the way that our bodies function, the way we function in society is we take in and gather information, process information, and then respond with other information. So you can see that mitochondria is critical if it's at the center of all of this in terms of the information gathering and sensing and responding. And so I don't know if you want me to just continue on. There's a lot that I can
Yeah.
share if
So
you have a
maybe,
question.
maybe a little short version of how the mitochondria interact with some of the other parts of the cells at a layperson's level.
Okay, so it actually, like I said, it's like an antenna. So you can imagine when you're in the car or listening to the radio, for people who still listen to the radio, or those of us that remember when you would dial into the radio station, it would be kind of fuzzy until you got to the exact station, and then it would be clear because it was tuning into a specific frequency that was emitted from a radio station somewhere else. So the mitochondria are like that, and they receive information and they are adjusted and attuned to natural frequencies of information that we have evolved under. So the frequency coming from the earth, what's called the Schumann resonance, known as like the heartbeat of the earth, or like we've talked about in the last few podcasts, the light frequencies, right? Those are all wavelengths. The mitochondria are very specific in terms of what frequencies and information they receive. And then what they do is they send out signals to, for example, the cell membrane to say, hey, everything's good in the cell. We've got the right information. You know, the immune system, don't worry, there's no threats here. We can just, you know, we can coast, or we can be relaxed. We don't have to be stressed and ready to fight something, or, you know, be on guard for something. As well, they also send signals to the DNA. So we know about our chromosomes and the DNA. And a lot of people think that our genetics determine our life and any disease processes, but the signaling from the mitochondria is actually where they go to the DNA and they tell the genes which genes to produce which proteins. So the mitochondria are very intimately connected to that. We think about those, if you understand epigenetics, meaning above the genes and the environment controlling the genes that are expressed, the environment is sensed by the mitochondria, and then the mitochondria send the signals to the DNA and the chromosomes and the genes to tell them what to respond in terms of what proteins to make based on that environment. I hope that was okay and not.
Yeah. No, that's great. And is that the production of energy? Is there something else involved?
So that, no, there's lots. So the mitochondria were taught in school, and I was taught in medical school, and most medical doctors still think that ATP is the energy currency of the cell, because the mitochondria, we associate ATP and mitochondria. So yeah, again, you can think of it as currency. And then along the way, we also make water and carbon dioxide and heat and what people understand as free radicals, which are considered by the average person not healthy for the body, damaging. So as it turns out, there's a scientist, I think he was also a medical doctor, Dr. Gilbert Ling, back in the 50s, who was also very good at math and mathematically calculated that the amount of ATP generated in the mitochondria, it was mathematically impossible that that was the energy currency of the cell, the sole energy currency. There was not enough. We could not make enough for that to supply our bodies with enough energy to do what it needed to do. And so along the way, some other people have hypothesized and now actually, I would say, verified that the water, so I mentioned that we were taught byproducts are produced. Water is one of those byproducts. Water is not a byproduct. Water is one of the key essential substances that is made by the mitochondria. And we've talked about hydration. There could be a whole talk about this particular water that is made, but it is a very special water that is made in the mitochondria. And I believe we talked in that hydration one about how water in our bodies is in a different phase, and it structures itself in such a way that there's a separation of charge beside biological surfaces. And so this water contributes to that. And so basically this water allows us to increase the energy battery in our bodies.
Oh.
And it is also what contributes to our true hydration in our cell, as opposed to what we think of as drinking water. That's necessary, but most of the water we drink, like we talked about before, for people who are not familiar or haven't listened, that goes mostly to our blood volume and some of the tissues, some of the extracellular tissues. But the real way that we are hydrated is from this water that is produced in the mitochondria. So the other things of note that are produced, there are some other things I'm just going to touch on, sort of main ones, but carbon dioxide we think of as a waste product. It's not a waste product. It's actually very crucial, again, for the ability to deliver oxygen to our cells. We also produce an infrared heat, and I think we've talked about that as well. We've touched on it. It's infrared heat, but it's also infrared light. So it's just an invisible light that we feel as heat. Now, again, that is also one of the signals for that the mitochondria sends out to tell our body what to do, but it's also something that helps us obviously stay warm, right? We are warm-blooded mammals, and it's important. And so that's why, for example, as a side note, people might have heard about cold thermogenesis, cold therapy, people doing cold plunges, ice plunges. So when we get cold on the outside, it actually changes the structure of the water inside and helps make the mitochondria more efficient. So how it does this, and all of these things that are made, water is made, I talked about carbon dioxide, the heat, the ATP, these are all made because of electrons being passed down what's called an electron transport chain. Okay, I'm not going to go into any more detail because I know people might just go like, okay, I'm out. But it's like, you can imagine just tossing going between stepping stones, and you're jumping between stepping stones. You got 5 stepping stones, and electrons go from one step to the next step, to the next step, to the next step. So electrons are the fuel for the mitochondria. So thinking about now the water, how I said there was a separation of charge with the water. So you have positive and negative. Now it's a battery. That negative charge comes from electrons. So the more body battery we have with this water, the more fuel we have for our mitochondria, right? Because our mitochondria use electrons as fuel to make the ATP, the water, the carbon dioxide, the heat, and what I mentioned, the free radicals. And so I'm just going to touch on that there because it's really important. Most people think that these free radicals, they're otherwise known as reactive oxygen species or reactive nitrogen species. Those are signaling molecules. Those are some of the molecules that go over to the DNA and in the genes and signal what proteins should be made. Now, they're very crucial. Without them, we'd have a lot of miscommunication. When we have too much of them, that's when there's a problem. That's where you've got like a loose cannon, and then you'll have, oxidation around the body, which is kind of like exposing a car to, to become rusty. If there's too much iron, it'll become rusty. That's kind of similar to what would happen in the body if there are too many. So again, as a side note, I would say that as a society, we have been focused on consuming a lot of antioxidants, thinking the more antioxidants, the better. But if you take exogenous, so outside sources of antioxidants, too many of them, and maybe not in the right environment or situation, you actually might be reducing the proper signaling that's actually supposed to take place.
Wow, that's more than I ever learned in science class. Biology 13, I'm from Ontario. So, okay, that's given a really interesting picture. So now what does that mean in terms of our lives, our day to day? Like, let's put that in, and hormones, and is it regulatory? What's next?
Okay, so there's a lot of things. I was just going to start with, you mentioned hormones. So mitochondria make a precursor steroid hormone for all of the steroid pathways. So that includes cortisol and our reproductive hormones, estrogen, testosterone, progesterone, estradiol, and so on. So if our mitochondria are not working well, and they're not making pregnenolone, that's the master steroid precursor hormone. If they're not making pregnenolone, you're going to have a problem with your cortisol pathway and your reproductive hormone pathway. So your mitochondria, they really are at the center of everything, but you can see how that is. So your mitochondria also make melatonin. So melatonin we talked about in another episode, but for those who have not listened to that, melatonin is one of the master circadian hormones that helps and signals the body to repair and regenerate, and which cells need repair and regeneration at night. Melatonin that is made in the cells is actually done by red and infrared light during the day, but it stays inside the cell. So it doesn't circulate in the blood volume. It's not the one that makes you tired, but it's made inside of the cell. And so it can do a lot of the repair and the cleaning up inside the cell. So I think I used the analogy last time, like if you've got a household with lots of people in the house and everyone's making a mess and kitchen dishes are put everywhere, and there's shoes and coats and dust accumulating, and you only have a couple of hours at night to do the cleaning, you're going to get backed up, you're going to get exhausted, and you're probably not going to get it done. So just more and more and more is going to accumulate. But if you do, I don't know, 10 minutes every hour throughout the day, then you can stay on top of things and your house maybe can stay clean. So that's similar to our cells. So if we want to make sure that we're making that melatonin, but because most of us spend 90% of our time indoors, we are very deficient in that red and infrared, and then therefore we are then deficient in the melatonin that we make during the day.
And so you're saying there are some technologies, either just go outside repeatedly throughout the day for a few minutes. That'd be the easiest. If you can't and you're inside all the time, maybe some of those red light things. We're going to do a whole episode on different technologies and techniques that we can use to help mitigate this. But let's return back to the mitochondria. You've got melatonin, you've got precursors to hormones, and it sounds like the mitochondria are the key to almost everything.
They are at the center of our health. And what's very interesting, bless you, what's very interesting is Dr. Doug Wallace is one of the leading mitochondrial researchers in the world. And from his research, he has shown that we can live with up to 70% dysfunctional mitochondria in our cells without knowing it. So without exhibiting any symptoms, thinking we are healthy. So lots of people walking around thinking they're healthy, they could have up to 70% dysfunctional mitochondria. So we're quite resilient.
Yeah. And how would we know? Like, you don't know. How would you find out?
I don't think there are any, I'm not aware of any tests at this point to be able to find out. But once you hit that 70% threshold, that's when you start to see symptoms. When you reach the 80%, that's when you start to become labeled with a disease. So if anyone has some type of label that they've been given by the medical industry, then you have at least theoretically 80% dysfunctional mitochondria.
Interesting. Would that also be true for somebody who's had thyroid issues, say their whole life? I'll speak myself. I've been working on thyroid issues for my whole life. Is that part of it?
Yes. So it depends where, like I said at the beginning, we have a different number of mitochondria in each cell, and depending on the tissue and organs in our bodies. So if you have more dysfunctional mitochondria in your thyroid, then that's where you will express the symptoms, potentially have a label of a disease.
Right. And it sounds like it's systemic. Again, we're a system of systems. So it's not just going to be in one little area of tissue, right?
Right.
Yeah. Okay. So go ahead.
Well, I was just going to say the other thing that is interesting as well is our mitochondria can sense danger. So there's again, Dr. Robert Navio is the one who studied this. He coined the term the cell danger response. And so what happens is when the mitochondria sense, I talked about them being antennas, when they sense, for example, stress, whatever stress that is outside of the cell, chemical, physical, emotional, they go into what's called cell danger response. And it's almost like a mini hibernation. They stop their functions and they go into a hibernation to conserve energy. And so you can imagine the less energy we're making, the less we're able to function, not just from fatigue, but all of the processes that the cells need to do in order for the body to work. So this cell danger, I'm not going to go into detail about it, but there's 3 different phases, but suffice it to say that someone else, a doctor, now I get not Lauren Picard, Martin Picard, get confused with the
Lauren Picard, Martin Picard.
Picard has studied the effect of emotional stress on the mitochondria. And for example, going to sleep stressed can reduce your mitochondrial function by 15 to 20% the next day.
Hmm.
So there's an effect, there's a stress that affects the mitochondria. And so really what we're doing when we want to optimize our health is we need to focus on the mitochondria and optimizing mitochondrial function. It really is at the center of our health.
So how do we do that?
I love that question. So we talked in previous episodes about light, aligning our life in conjunction with circadian rhythms, optimizing our circadian rhythms. So our lifestyle follows those. That is what is loved by mitochondria.
Now, I know we have a whole episode on circadian rhythms, and we can't recover that here. But for the purposes of this discussion and mitochondria, can you give a little overview there?
Yes. So, okay. So there's that part, and that has to do with optimizing your light environment as well. So the stuff that, again, we talked about, seeing sunrise, light, getting as much natural light in your eyes, naked eyes. So no glasses, no sunglasses, not behind windows, having doors open. Light is really key. Getting connected to the earth. So earthing. Because as much as many people still consider that a woo-woo thing, if you talk to any scientist, they understand that the earth is full of electrons. It's got this electrical charge, and we are electromagnetic beings. And so when we are connected to the earth, we pull in, we are connected and we pull in electrons. And I was talking about how electrons are the fuel for the mitochondria. So it's like a free energy resource to be connected to the earth. It doesn't mean you have to have bare feet on the ground. I mean, that's a great way, but earthing can be done through concrete, earth, grass, I think marble, even, what do you call them? Bricks,
Tiles.
Even if you have like a concrete or a post, like a signpost that's stuck into the ground, and you touch that signpost, it's metal, you can ground that way. Touching a tree is grounded. Anything, flowers, leaves, that can all be grounding. So it doesn't have to be bare feet, even, because I know in winter people say, well, how am I supposed to go out? We also have other things that tools that you can use, grounding shoes. There's grounding products. I tend to stay away from a lot of them because there's controversy over the potential that it can actually be harmful. It can be a conduit for dirty electricity, for example, with grounding sheets, if you don't buy good quality and ones that are done properly. So eating seafood, I know this sounds kind of odd or off, but food in general is only 1/3 of a source of our electrons. So 1/3 is food, 1/3 is the earth, and 1/3 is the light. So seafood, in particular, oysters are at the top of the list. I can't handle oysters. I just absolutely cannot, but they are an absolute superfood when it comes to electrons, when it comes to that DHA that most people understand is found, that omega-3 fat that's found in seafood. it is actually only found, the proper formation that we use as humans is only found in the actual seafood. It's not found in the supplements. So that's an aside. Fish oils don't do what we are led to believe they do.
We could have a whole other conversation on that too. There are so many that arise. Okay, let's leave that one for now. So I think that's fascinating. 1/3 food, 1/3
The earth.
the earth and grounding in electrons, and then 1/3 light. That's phenomenal. And we have not been taught about light, hence this series. Okay, so let's take this to the next level then. So we need to pay attention to our circadian rhythms. We need to ground. About how much grounding do we need to do a day? What does that mean?
Oh, sorry, it was just choppy there.
Okay, it's probably my internet. We'll look at that later. So I'll repeat. How much grounding then do we need to do in a day, whatever that means, or whatever that looks like?
Okay, so that is dependent on what's going on in your body. So someone who, for example, is healthy and not experiencing any symptoms can probably get away with a lot less time grounding. Someone who is experiencing symptoms, has a disease, you're going to want to do more. So it depends who you talk to, and you have to really tap into what feels good for you and what you're experiencing as an N of one. In research, we have an N number of subjects, but really we are all an N of one. So we can't blanket everybody with the end result of what should be done, even though that's how the modern medical model works. That's not how things should be done. So really you want to experiment. I would say you'd want to get a minimum of 15 minutes a day. Some people say a minimum of an hour a day.
Mhm.
Again, if you're sick, you're going to want to go probably to, if it were me, if I were sick, I would want to go to the tropics. I'd want to be connected in the sand every day, in the ocean, under the sun, bathed by the natural frequencies, because that you need an overwhelming amount of good frequencies for your mitochondria to overcome, depending on how ill you are, right? It really, there's a balance, and it's a seesaw. And so it's hard for me to give
Right.
a number.
But that's a good starting point. So just to say, but if you're more compromised, you're going to need more. I love that. And now let's take that to light. So we've got 1/3 food, 1/3 grounding, 1/3 light. So what does that mean? I know we're going to explore all the technology, but just simply, how much light? How many times a day should we be out in it? If we can't be barefoot, running around outside all day long like little kids used to do, I don't even think they do that anymore. What does that mean? How many times a day should we be out for a couple of minutes? I know you talked about sunrise, sunset, etc. Let's revisit that for a few minutes.
Okay. So what I would say at sunrise, you'd want to at least sync your brain clock to the sunrise light. And so I would say at least 2 to 5 minutes to get that sinking in. Then we get to the next point at ultraviolet A rise. So it's about an hour after sunrise. And if you can get out at that time for like a walk, if you can schedule something outside, if you're driving your kids to school at that time with windows open, or if you're going to the grocery store, or if you're playing with your kids outside or having breakfast or something, to at least get 15 to 20 minutes outside at that time. And then really you would want to, as much as you can, say every hour or 2 hours, really just take a light break. I mean, people accommodations to do smoke breaks, even still to this day, right? If you need a smoke, you need a smoke. They're going to go outside. Well, this is for your health. You need to get some light. You go outside to get some light, even if it's just for a couple of minutes, because it really quite quickly.
I love it. That's the first time you've said that so far in the series. A light break about every hour, if you can, like do as much as you can. This is not about perfection or even optimal. We're just saying, let's get some light breaks. Who would have thought? Nobody told us to get light breaks. This is so important.
Yes.
Wow. All right. As go ahead.
And I was going to say, we're talking about light and mitochondria. So we've got, without going into too much detail, again, those steps I was talking about in the mitochondria, two of those, one which is the motor that makes the ATP, and then the step before that is called cytochrome C oxidase. Those are both red light, what we call red light receptors, chromophores. So they respond to red light. So if they are sensing red light directly, they work better. So that fourth step, if you're receiving red light, then you're going to make more of that water. We call it metabolic water, deuterium depleted water. You can hear different terms. And we want more of that water made. And we will also be churning out more ATP because the motor is increased in efficiency just from red light. So we can make more energy just from red light without eating food, which we're kind of conditioned to believe that's where we get our energy. That is one of the reasons why I have loved red light panels, because you can stimulate energy. And when we have more energy being produced, we basically have, again, like a cell phone is just the most common analogy and the one that most people can understand and appreciate. When you have a full battery in your phone, you can use all the functions in your phone. The same with our body. When we have enough energy, then everything can work. When we have a depleted energy, we've got a 50% body battery. Well, it's got to prioritize where that energy is going to go. And so some parts of your body just are not going to work very well.
Right. Which probably most of us at a certain age or approaching a certain age are starting to experience this because we haven't, let's just use one example, because we haven't had light breaks and we haven't grounded because we just don't prioritize that. We don't know about it, or we haven't known about it and we haven't prioritized it. So there's another question I want to ask you. So you referred to this, but I'd like to be even more specific. How do the mitochondria become dysfunctional?
Okay.
What are some of the things that?
So well, we've got lots in our environment that are harming us and being disconnected from nature. But the light, the artificial light, so the blue light and then the invisible light frequencies are a really big deal. And they are kind of, I mean, there's I would say like a section of society that understands that, but the general public still doesn't. I mean, everyone still walks around with AirPods in their ears, and it's basically like sticking your head in a microwave. What happens is with these foreign man-made electromagnetic frequencies that really we are bathing in, and there's a lot, we can do stuff in our immediate environment, but for example, with 5G, it's difficult. But what happens is the mitochondria actually, so we have calcium coming into the cell as a regular occurrence. It's a co-signaling agent, and we've got measures to then take the calcium out of the cell. So we've got calcium coming into the cell and then calcium being taken out of the cell as a normal occurrence through these special channels. Well, these man-made electromagnetic frequencies actually keep those channels open. So there's an influx of calcium constantly into the cell. And so those measures, those measures to extrude the calcium get overwhelmed. So the mitochondria actually says, okay, we got to pause all of our functions and go help get rid of this calcium. And so that is a big issue. That is one of the big ways that mitochondria then can become dysfunctional. And what happens is they become dysfunctional. The membrane becomes dysfunctional. The electrons that are getting passed from one step to the next, when there's swelling in the mitochondria, then you can imagine, for example, these stepping stones, like a river and stepping stones across a river. If you've got a 10-foot river and you place those, you have 5 of them, you place them 2 feet apart, you can jump across the river. But now imagine spreading it out to a 100-foot river and you still only have 5 steps. Well, if you're going to try to jump 20 feet, you're probably going to get lost in the water. And what happens is that's what happens to electrons. Mitochondria swell. They get lost and they don't like to be unpaired. So they try to find something to pair up with. And then they make more of those free radicals that we were talking about earlier when I said when there's too many, then they can overwhelm the body and start causing damage everywhere. And that's what happens. They cause damage to the cell membrane. They cause damage to the mitochondrial membrane. They cause damage to the proteins. They just go around and cause damage everywhere. And then it's like a vicious cycle, because the more damage they cause, the more swelling happens in the mitochondria, the more they're going to produce these.
Right.
Radicals.
And you had mentioned a number of other substances. So you talk about EMFs. We're hearing so much controversy. So thank you for explaining why. And you talked about statins, glyphosate, fluoride, cell danger response. You've mentioned that already. Can you talk a little bit about statins, glyphosate, and fluoride? Just briefly. I know they could be huge subjects on and of themselves.
Okay. So let's start with statins, and I'm just going to talk about this one area of statins, but they are literally a mitochondrial poison, because in those 5 steps I was talking about, one of the steps requires to get from the electrons to go from one step to the next requires something called CoQ10. Now, a statin specifically takes out CoQ10. So if you don't have that, your mitochondria are not going to be working properly. You're not going to be able to get the electrons from one step to the next.
Right. So we can maybe leave that one there and just say, why are we still prescribing this? But that's another conversation, right?
And the fact that lowering cholesterol, our brains and our nervous system and our cell membranes are made up of, and our hormones are made up of cholesterol. So lowering cholesterol can be very damaging to our body.
Okay. Glyphosate.
So glyphosate is an interesting one, and I know there's a lot more for me to learn about it, but glyphosate has a similar structure to glycine, and our collagen in our body. So collagen is the most abundant protein in the body. Collagen is about 70% of the protein. And I'm not sure if we talked about it in any of these episodes, but I do mention it a lot in my other talks that I give, that it literally makes up the communication superhighway in the body.
I know we haven't talked about that much.
So the fascia in our body literally connects everything, including inside the cells. So collagen is extremely important. It is organized in a way where there are 3, it's a triple helix. We've heard about DNA being a double helix, 2 strands being wound around each other. Collagen is a triple. And the way it structures itself is such that there's a nanotubule of water in the middle. And water is the means by how light travels in the body. So we've got this super quantum highway of light communication through water because of fascia and because of collagen. So I'm bringing this up because collagen is made up of a 3 amino acid repeat structure. Every 3rd amino acid is always glycine. The other 2 can be different, but every 3rd one is glycine. Glyphosate can, when it gets in there, can replace that glycine, but it then destroys that structure.
So all of the people who have lower collagen, lower elasticity in our skins, that's the outside mirror of it, and we're trying to take collagen and replace it, perhaps that's not the solution.
So we have a better solution to make our own collagen. I think that, there's a couple of things. I have heard some people say that taking collagen really works for them. A mentor of mine says when some people say that, she just lets them take it. There's another side to taking, for example, other supplements from outside and how loaded they are with deuterium, which we haven't talked about here. We talked about, I think, briefly in the hydration.
Mm-hmm. And it's coming up in one of our subsequent next episodes.
So that's one of the reasons I would personally stay away from it. Never mind that we have ways of making own. And I would prefer, me personally, and I try to encourage people that the best way and the way we were designed was to be making our own
Right.
substances.
Absolutely. And there are solutions for this. And we'll get into that in our final episode as one really key solution, a phototherapy technology. So the last one, fluoride, I'd love to touch on that before we close today.
Okay. So fluoride it's a known neurotoxin. So that is, and I have this, actually, I think we were talking earlier, I have this talk recently that someone did who was a pediatric dentist and oral surgeon, and she was talking about fluoride. And so it's a known neurotoxin, first of all. It's an electron stealer. So I just talked earlier about how electrons are the fuel for the mitochondria. It's an electron stealer. It also does something that's called, it lowers the dielectric constant of water. And so I know that might be like a big verbiage for people, but basically what it does is it lowers your body battery that we talked about, that water, that there's a separation of charge, and the bigger the water, that water layer we have, the more energy, potential energy we have. It lowers that, and it lowers our ability to actually store energy in the body.
Okay, so the question, very briefly, why is it still being prescribed and as a standard dentistry ingredient, and is in so much toothpaste and is even in so many of our water supplies?
And
help me understand.
and medications. It's
Yes.
medications too. So what we hear back from professionals and so-called experts is that it's such a low amount that it is not as problematic. But what I've heard is, first of all, it's never been studied in conjunction with all of the other toxins that are in our bodies that we're being bombarded with, and aluminum and lead, and like you said, we've got glyphosate, and we've got all other, things that are maybe injected. And when we talk about, and I've been sharing all this information about, this is kind of the new paradigm of understanding quantum biology, but with quantum biology, small, tiny changes can have a big impact and have big changes on our biology. And so I think we've been misled, and people just perpetuate what they've been told. And I mean, I could give an answer, which I'm not going to here, about why I think it's still in the water and in the medications and in our toothpaste, but I think that's for maybe a different platform, but it doesn't make any sense to me.
Right. Well, thank you for your opinion. And I know that we're providing this information for educational purposes only, and you have to make your own choices and own decisions and do your own research. And we're going to have extensive notes in this whole series. You can do some exploring, and we will provide you other avenues to do that. So, Rachel, to leave us today, is there anything else you need to say in this short conversation about mitochondria to wrap us up?
What I would say is that our mitochondria, we need to tend to our mitochondria if we are tending to our health. And I mean, I know I went through a lot today, and I can go much deeper, and it's a big subject, but really, once again, the strategies are simple. Getting more natural light in your life, aligning your lifestyle with the light and dark cycles, and really being mindful of it, blocking artificial light at night, connecting to the earth, one step at a time. It doesn't have to be huge, big steps or for long periods. Really, one small step at a time in the right direction, thinking about your mitochondria. I mean, we didn't even talk about, I was just thinking now about how mitochondria get repaired, right? If we're not doing the repairs, then we're actually destroying more and more mitochondria. And that takes place at night, right? Being careful with that artificial light and blocking artificial light. Then it gives time to also repair the mitochondria at night, not just our cells.
Right. So the key, one step at a time. It is important. Perhaps this subject might be one of the most important that we cover. And light. Again, food, grounding, and light, 1/3 of our time. Thank you so much again for your time, your wisdom, your expertise, and the years of study that you've put into this, Rachel.
Thank you so much for having me.
And we're doing this because you matter.